Hello dear students of plus one medical, non-medical, respected teachers and dear friends. In this video I am going to discuss about the formation of beats and beat frequency. So first of all, what are beats? When two tuning forks of slightly different frequencies, difference should not be more than 10. So when two tuning forks of slightly different frequencies are sounded together, then we listen a series of rise and fall of sound at regular intervals of time. This phenomenon is known as beats. The formation of one rise and one fall is called one beat. And number of beats produced per second is equal to the difference in frequencies of the two tuning forks or sources. And we are going to prove it both graphically as well as analytically. So first graphical method to produce beat frequency is equal to difference in frequency of the two tuning forks. Suppose we have two tuning forks A and B having frequency 6 Hz and 8 Hz, suppose respectively. Now both these tuning forks are sounded together. Now what happens at the end of 1/4 second? After the tuning fork sounded, what happens after the end of 1/4 second? Now since this tuning fork has frequency 6 Hz, tuning fork A, it means it will produce 3 beats per second, 6 beats per second, whereas tuning fork B will produce 8 beats per second. This is the meaning of frequency. Now at the end of 1/4 second, how many waves will be produced by tuning fork A? 1/4, that is 3/2. So we get one crest, one trough and one crest. Suppose at the end of t is equal to 1/4 second, 6 Hz tuning fork will produce 1.5 wave. Tuning fork B will produce 2 waves, 1, 2. Now what we listen? At the end of 1/4 second, crest of one is falling upon trough of other. It means amplitude is minimum and hence intensity is also minimum because intensity is directly proportional to amplitude square. This is shown in figure 1. What happens at the end of half second? Tuning fork A having frequency 6 Hz will produce 3 waves, complete 3 waves, and tuning fork B will produce complete 4 waves, 1, 2, 3, 4. And what we see at the end of 1/2 second, trough of one is falling upon trough of other when they superimpose upon each other. So they will superimpose upon each other. So trough is falling upon trough of other, it means amplitude is maximum. Therefore, intensity is maximum. It means during half second, we listen one minima and one maxima. It means in the next half second, there will be one minima and one maxima. Sorry. It means during 1 second, 2 minima and 2 maxima are produced. So formation of 1 minima and 1 maxima is called 1 beat. It means 2 beats will be produced. So it means number of beats produced per second is equal to 2, which is nothing but difference in frequency of two sources. 8 minus 6 is also 2. So it means in general, difference in frequencies of the two sources or tuning forks is equal to number of beats produced per second or beat frequency. So this is graphical explanation of this beat frequency. Now, analytically, we can also prove. Now, suppose again two waves of slightly different frequencies, nu1 and nu2, or angular frequency omega and omega2, amplitude is same, traveling in the same direction, superimposed upon each other, so that we get maximum and minima at regular intervals of time. So for first wave, y1 is equal to r sin omega 1t is equal to r sin 2 pi nu 1t, equation number 1. y2 is equal to r sin omega 2t is equal to r sin 2 pi nu 2 into t, equation number 2. Then we have principle of superposition. When they superimpose upon each other, resultant displacement is given by y is equal to y1 plus y2. Or y is equal to r taken as common sin 2 pi nu 1t plus sin 2 pi nu 2t. This is sin C plus sin D. So sin C plus sin D is equal to sin C plus D by 2 cos C minus D by 2. So applying this formula, CD formula, so we have y 2r sin 2 pi nu 1 plus 2 pi nu 2 upon 2 into t. So we can write 2 pi into nu 1 plus nu 2 into t upon 2 cos 2 pi nu 1 minus nu 2 into t upon 2. 2 2 cancels. So we get y is equal to 2r cos pi nu 1 minus nu 2 into t sin pi nu 1 plus nu 2 into t. The coefficient of sine gives the amplitude of the resultant wave. It means amplitude of resultant wave varies with the time, because r is the amplitude of individual waves, superimposing waves, so which is constant. So 2r is constant, but cos pi nu 1 minus nu 2 into t will vary with time. So to find condition of maxima and minimum, so for minimum intensity, amplitude should be minimum. Amplitude means 2r cos pi nu 1 minus nu 2 t should be minimum. Minimum means 0. Or cos pi nu 1 minus nu 2, because 2r is constant, into t should be equal to 0. And it is 0 when cos of odd multiple of pi by 2, where n is equal to 0, 1, 2, 3 and so on. Odd multiple of pi by 2. So 2n plus 1 into pi by 2. It means pi into nu 1 minus nu 2 into t is equal to 2n plus 1 into pi by 2. So pi cancels. So we have t is equal to 2n plus 1 upon 2 into nu 1 minus nu 2. So putting n is equal to 0. So this gives time at which various minima will occur. So various minima will occur at n is equal to 0, that is 1 upon 2 nu 1 minus nu 2. When n is equal to 1, that is 3 by 2 nu 1 minus nu 2. When n is equal to 2, that is 5 by 2 nu 1 minus nu 2, and so on when n is equal to 4. So it will be 3, 7 by 2, 9 by 2 and so on. It will be odd multiple of 2 nu 1 minus nu 2, 1 by 2 nu 1 minus nu 2. So it means we can find time interval between two consecutive minima. So subtract 3 upon 2 into nu 1 minus nu 2 minus 1 upon 2 nu 1 minus nu t comes to 1 upon nu 1 minus nu 2. Any two consecutive interval, time interval between two consecutive minima comes out to be 1 upon nu 1 minus nu 2. Say equation number 5. Similarly, therefore frequency for minima, frequency of minima will be nu 1 minus nu 2. Time interval is 1 upon nu 1 minus nu 2. So reciprocal time interval is called frequency. Now for maximum intensity, amplitude should be maximum. Means cos pi nu 1 minus nu 2 t is equal to maximum, means it must have value plus minus 1, because square of amplitude is also positive. So it means cos of pi nu 1 minus nu 2 t is equal to cos of n pi, or n is equal to 0, 1, 2, 3 and so on again. When n is equal to 0, cos 0 is 1, n is equal to 1, cos pi minus 1, n is equal to 2, 2 pi again, plus 1, minus 1, plus 1. So when cos of n pi, so pi in pi cancels, so nu 1 minus nu 2 into t is equal to n pi, pi cancels, t is equal to n upon nu 1 minus nu 2. So this gives time, instantaneous time at which various maxima will occur. So the various maxima will occur at t is equal to, put n is equal to 0, 0, 1, 1 upon nu 1 minus nu 2, 2 upon nu 1 minus nu 2, 3 upon nu 1 minus nu 2. At all these and so on. So various maxima will occur. So therefore, we can find time interval between two consecutive maxima. So 1 upon nu 1 minus nu 2 minus 0, that is 1 upon nu 1 minus nu 2. 2 upon nu 1 minus nu 2 minus 1 upon nu 1 minus nu 2 is again 1 upon nu 1 minus nu 2. So it means this is question number 7. So time interval between two consecutive maxima is 1 upon nu 1 minus nu 2. Similar time interval between two consecutive minima is 1 upon nu 1 minus nu 2. It means time interval during the formation of beats, time interval between two consecutive maxima and two consecutive minima is equal to 1 upon nu 1 minus nu 2. In other words, time interval between two consecutive maxima and time interval between two consecutive minima are equal. That's why maxima and minima occur at regular intervals of time by definition of beats. So therefore, frequency of maximum is also nu 1 minus nu 2. So therefore beat frequency. So beat frequency is given by 1 upon 1 upon nu1 minus nu2 or is equal to nu1 minus nu2. This means number of beats produced per second or beat frequency is equal to the difference in frequencies of the two sources or two tuning forks. So difference in frequency of the two tuning forks. So this we have proved. So again, what are beats? When two tuning forks of slightly different frequencies are sounded together, then we listen a series of rise and fall of sound, and this phenomenon is known as beats. And the formation of one rise and one fall is called one beat, and the number of beats produced per second is equal to difference in frequency of the two sources. Why they should have nearly equal frequency or difference should not be more than 10 even. It should be always less than 10. 2, 3, 4. You'll get better beats if difference is less. Because our human ear cannot differentiate between rise and fall of sound. So its the sensitivity has a limit. So if it is more than 10 or approaching 10, so we cannot identify or recognize rise or fall of sound. So that's why when difference is 2, 1, 2 or 3, 4, then we can identify or recognize rise and fall of sound, and we can clearly observe the formation of rise and fall of sound and hence beats. So beats produced per second is always equal to difference in frequencies of the two sources. So this is all about what are beats, what is beat frequency, and how beats are produced. And beat frequency is equal to difference in frequency of two sources by graphical method as well as analytical method. So till next video, stay tuned, be happy, all the best, good luck.